Today for day 2 of circles, we're going to be looking at 3 items: circumference, arc length, and the area of sectors in circles. And I know that's really zoomed in here, so I apologize. I will try to shrink that down just a little bit. Typically when we're here in person, we start off with this warm-up question, and I kind of ask you to think through this. So it says the bicycle wheel shown at the right travels 63 inches in a complete rotation. If the wheel were to only turn 120 degrees about the center, how far would it travel? So I would encourage you to think through this question, pause the video here, kind of think about what different strategies you could try, and then we're going to kind of talk about how does that relate to what we're going to learn today. So essentially there's several different ways that you can answer this question. However, our final answer should be 21 inches. And I'm going to kind of talk through why that is here in a little bit. So for sake of time and just to kind of get us rolling, we're going to move forward. So what you've just discovered here is how to find the arc length of a circle, or the distance around a curve. So what we're doing is we're finding a portion of the entire distance around the circle, but the entire distance around the circle we call the circumference. So basically there are 2 strategies that you can think through. You can think through the part of the total equals the measure out of the total. We can set up a proportion and cross multiply. So basically the arc length, or the part of the circumference out of the total circumference, equals the measure out of 360. Our other option is if we were to solve this for the actual arc length, we find that the arc length is equal to the measure out of 360 times the circumference, or 2 pi r. I would recommend that you write both of these formulas down, and it's up to you which one you want to use because they're both meaning the same thing. So basically, if we're trying to find the length or the distance of this red arc, we want to make sure that we use either the ratio set equal to another ratio or use the formula. So for sake of being consistent, I'm just going to apply the formula, and the formula says our measure out of 360 times circumference should give us that length of our figure. Or if we wanted to set it up like we did before, we could say the measure out of 360 equals how much out of 2 pi r. So either way you want to do that is up to you. Like I said, I'm going to stick with the formula here, the measure over 360 times 2 pi r. So basically we have 60 out of 360 times 2 times 8 times pi. And notice I did rewrite that here because when we're multiplying, we can use that commutative property and we can rearrange the r and the pi here. And the reason I'm going to do that is they do say to leave our answers in terms of pi. That means the pi symbol should still be part of your answer. So we're going to find all of the numeric components, 60 divided by 360 times 2 times 8, but we're going to leave pi as part of our answer. And with that, I'm going to try to rewrite this in as nice format as I can. So I end up with 2.6 repeating, which we know is 2 2/3 pi. So I did all of this numerical component here and left pi as part of my answer. When we write our answer, since this is a distance, right, we're finding the length, we're going to make sure we include centimeters. So my arc length for that first picture is 2 2/3 pi centimeters. So for picture B, we again have 60 out of 360 times 2 times 11 times pi. So 60 out of 360 times 2 times 11 is 3 2/3 pi centimeters. And last but not least, we have 120 out of 360 times 2 times 11 pi. So 120 out of 360 times 2 times 11 gives me 7 1/3 pi centimeters. So again, that 1/3 is coming from 0.3 repeating, and the 2/3 is coming from 0.6 repeating. So for this section here, you're going to try some of these on your own. So we're going to highlight, I know it's a little hard to tell what is actually boldened here, so you may want to kind of bolden that on your own. And we're going to do a couple together, and then we're going to move forward. So for arc length, again, we want our measure of our angle out of 360 times 2 times pi times our radius. So we're going to rewrite that with our radius first. We're then going to multiply the numbers out front, and we end up with 6 pi inches. Now for the next one, we don't know the measure of that arc, but we know the one beside it is 30 degrees, and we have a diameter right here forming a semicircle from here to here, which we know should be 180 degrees. So if I've got 30 degrees here, I've got 150 degrees here. So I'm going to say 150 out of 360 times 2 times pi times my radius, and since 18 is my diameter, my radius is 9. So 150 out of 360 times 2 times 9 gives me 7.5 pi feet. So again, guys, what we're finding here is the distance. We're saying if this was a real circle, how far did we walk from here to here? So we found that curvature's distance. The reason we often leave our answers in terms of pi is if we ever end up in a job where we cannot round, meaning it's a life and death situation if we round something too early, we want to make sure that we can give a confident answer and an accurate answer that is easy to look at but also represents all of the components of the formula. So we want to make sure here that we leave our answers in terms of pi anytime they tell us to do so. And if they don't, then we can simply just round it like we normally would. So for the next question, we know that we've got a full 360. I've used 45 of that. So I've got 315 out of 360 times 2 times 20 times pi. So 315 out of 360 times 2 times 20 gives me 35 pi. I would recommend that you try the next 3 on your own and then come back to check. For this one, you should end up with 18 pi. For this one, we should end up with 8.2 pi. And I left off my units on the first one, so forgive me, I'm going to double that. That should be inches. The next one is meters. And then here, because this is 60 degrees, that means this angle is 60 and this one is as well, since those are vertical. So I've got 60 out of 360 times 2 times 15 times pi, or 5 pi feet. So again, guys, what we found is the distance along that curve using the arc length formula. So now we're going to use arc length in the context of finding the perimeter of a shape. So if I notice, I've got a straightaway here that's 13. I've got a straightaway here that's 13. So as far as perimeter goes, I already know those 2 edges. But then I also have this half of a circle here and this half of a circle here, or 2 semicircles. Now, since they both have the same diameter of 6, I can conclude that they're the same size. So with that, I have half of a circle and half of a circle, which makes a whole circle. So all I need to do is add on the circumference of that circle using 2 pi r. Since my diameter is 6, I know that my radius is 3. So I've got 2 times pi times 3, or 26 plus 6 pi. Now, if we're leaving our answer in terms of pi, I cannot combine any further, just like if that were 26 and 6x, we couldn't combine. So with that, if we're told to leave it in terms of pi, this would be our final answer. However, if we're not and they tell us that we can round, we are going to use the actual pi button on our calculator. We're not going to use the rounded 3.14. So when I hit enter there, that is approximately 44.8 units. Since they didn't specify on this particular question to leave it in terms of pi or not, I would accept either answer. For the next one here, we also have this straightaway that's 6 and this straightaway that's 6. So as far as perimeter goes, we already know those two distances. Then I have a quarter of a circle here because that's 90 degrees, so that's 1/4 of the circle. And I've got another 1/4 of the circle here, so I have half of the distance around the circle, so half of 2 pi r. So if I look at what I've got next, I've got 12 plus, and if I multiply here, half of 2 is 1, so I really just have pi r. And so 12 plus, my radius is 3, so I'm going to write that coefficient first. So if I'm leaving my answer in terms of pi, 12 plus 3 pi. And if I'm rounding it, again, make sure that you use the pi button. 12.14 units is my approximate perimeter. Then we're going to find the perimeter of this funky little shape here. Again, look for your straightaways first. So we've got 41, 41, 11, and 11, which are our straightaways. So if I go ahead and add those together, I end up with 104. Plus, I've got a quarter of a circle here, a quarter of a circle here, another quarter, and another quarter. So I have an entire circle, and they're all the same size it looks like here in terms of as far as I can tell. So I've got to figure out what is the radius of that actual figure. Well, because from here to here is 11, if I cut that in half, I've got equal parts on both sides. So 11 divided by 2 tells me that my radius is 5.5. So now I'm going to say 104 plus 2 times pi times 5.5. I'm going to multiply these guys here since those are both whole numbers. And 2 times 5.5 is going to give me 11 pi. If I'm leaving it in terms of pi, that is my final answer. If they tell me to round, my answer is approximately 138.6 inches long. You'll notice on the answer key for your homework, you're going to see some questions that look like this, meaning they have two answers. They have the in terms of pi answer and the rounded answer. Now we're going to shift into talking about a sector of a circle. So a sector of a circle is a region bounded by 2 radii of the circle. And radii is a funky looking word that just means the plural of a radius. So it says we've got 2 radii in that circle and we want to find the space in between them. So I like to think about a sector of a circle as kind of a slice of pie or a slice of pizza. So with that, we know how to find the area of a circle already, or hopefully we do. So our area of a circle formula is pi r squared. So if I want to find part of that circle, I can say the area of the sector over the area of the circle should be proportional to the measure of the arc out of 360. Again, you have a secondary formula here. If you solve that equation for the area of the sector, it's the measure out of 360 times pi r squared. I would jot both of those down in your notes, and you may use either interchangeably. For sake of consistency, I'm going to stick with the actual formula, which says the measure out of 360 times pi r squared will give me my area of the sector. So you'll notice we've got a red sector and we have a blue sector, and it does say to find the areas of both of the sectors, plural. So I'm going to start first by doing 70 out of 360 times pi times 8 squared. Now if I'm leaving this in terms of pi, which it doesn't specify, so I would take either answer, we end up with 12.4 repeating pi. Since 0.4 is repeating, we could rewrite that. Any number that repeats like that can be rewritten as over 9. So 12 and 4/9 pi. And since this is area, our units are always squared. Again, it doesn't specify that it has to be in terms of pi here, so if you just typed every bit of that into your calculator, that would be totally fine with me. Now our other sector is whatever 360 degrees is minus 70. So we've got 290 degrees for that blue arc. So 290 out of 360 times pi r squared. If I want to leave that in terms of pi, I'm going to multiply all of the numbers that are not pi. So I end up with 51.5 repeating pi, which, like I said, any number that repeats like that we can write as over 9. So 51 and 5/9 pi units squared. Again here, guys, if this were on a test or quiz, I'm not likely to give you any of those that you would have to write as over 9 or something like that. It would hopefully be a little bit nicer answer, but that is a neat little trick to just kind of recognize as something that might be helpful to you in the future. So you've got a couple of examples here. I'm going to do 12 and 13 with you, and then I would recommend that you try the other 4 on your own. So remember, our formula is measure out of 360 times pi r squared. So plugging in what we know, we've got a 45 and a 90 here, so we've got 135 out of 360 times pi times 2 squared. So again, I'm going to multiply all of the regular numbers here, and I'm going to keep pi as part of my final answer. So I end up with 1.5 pi units squared. Now guys, this is where you want to be careful. If you leave off pi, which is easy to do, right, because we see 1.5 in our calculator. If you forget pi, that is actually a big deal, because 1.5 times pi is something totally different than 1.5. So that is a key component that you want to make sure you don't forget about the pi in your answer, or you will lose points because they're not the same thing. For the next one, we know that we've got 72 degrees here and that diameter drawn for us. So we've got 108 degrees here by subtracting from 180. So 108 out of 360 times pi times 5 squared. In this case, it does specify that we have to leave this in terms of pi, so make sure you're doing that. We end up with 7.5 pi units squared. Go ahead and try the remaining questions on your own, and then come back to check your answer. Now I did leave off all of my units there, so do make sure that when you give your answer that all of these have units squared as your answer. And don't forget that pi symbol, like I said, or that will make a big difference in your final answer. So picking back up where we left off, we're now going to look at some information that we have here. It says a rectangular wall has an entrance cut into it. You want to paint the wall to the nearest square foot, so that tells us how we're going to round. What is the area of the region you need to paint? So first and foremost, the largest object that I see here is a rectangle. So I'm going to start first by finding the area of the rectangle, and then I'm going to look at what other pieces have been cut out. So I notice that there's this figure right here that has been cut out. That's 16 across the top and 16 across the side, so that's a square. So from that rectangle, I'm going to subtract the area of the square. And then from that, I also have a semicircle here, or a half circle, so I'm going to subtract half the area of the circle. So with that, my rectangle is 36 by 26, so I'm going to say 36 times 26, which is 936, minus the area of the square, which is a 16 by 16, so that's an area of 256, and then minus half of pi times my radius squared. Now since this distance across is 16, that's my diameter, so my radius is 8. So half of pi times 8 squared. Since this says I can round to the nearest square foot, I can now type every bit of that into my calculator. 936 minus 256 minus half of pi times 8 squared. Again, be sure to use the pi button here. And we've got approximately 579 square feet that we need to paint. For these next questions here, we're finding the area of the shaded region. So again, we kind of want to look at what shapes we have. So I notice that we've got this figure here that's a 6 by 6, so I've got a square. And then I'm going to start by finding the area of that square. And then I've got a semicircle here and a semicircle here. So two semicircles make one circle. So I'm going to subtract the area of that circle. So starting off, I've got a 6 by 6 square, that's an area of 36, minus pi times my radius is half of that 6, so 3 squared. And in this case, they do not specify if they want this in they do not specify if they want this in terms of pi or rounded. So if they want this in terms of pi, I would say 36 minus 9 pi. If they want it rounded, I'm going to go ahead and type that in my calculator and say that's approximately 7.7 square meters. So either of these answers would be accepted as correct, since they do not specify which one they want. For this one, we're also going to start with the area of that 20 by 20 square. Then we're going to subtract 4 times the area of the circle, since we have 4 of those. So I've got a 20 by 20, that's 400 square inches, minus 4 times pi times my radius squared. Now I'm going to have to do a little digging here to find the radius. So I know all the way across here is 20, which tells me that I've got 10 for my diameter. So I've got 5 for my radius. So if they want me to leave this in simplest radical form, if they want us to leave this in terms of pi, I have 400 minus 100 pi. I can't combine those because one has a pi and one doesn't, but since they haven't specified, we're going to give the approximate answer as well. So that's approximately 85.8 square inches. Either one of these answers would be acceptable. Last but not least, we're going to talk about what's called a segment of a circle. And a segment of a circle is this thing that kind of looks like a banana here. It's that outer edge bounded by a chord and the edge of a circle. So to figure out the area of that segment of the circle, we're going to start by finding the area of the entire sector. Then we're going to find the area of this triangle here, and then whatever's left over is that segment of the circle. So, taking a look here, we've got the area of the sector for step 1. We're going to find by the measure out of 360 times pi r squared. I'm going to try to leave this in terms of pi until the very last possible second. So 60 out of 360 times 18 squared, that's 54 pi. And since this is area, that would be inches squared. For step 2, though, I've got to try to find the area of this particular triangle. So I'm going to manipulate this and make this just a little bit smaller here so that we've got a little bit of space. And looking at that triangle, I really have a figure that looks like this, where I have 60 and 18. So to find the area of a triangle, I know that that's 1/2 the base times the height. So I already know that the base is 18, but what I need to know is how tall is this figure. So off to the side, I'm going to go ahead and sketch the height here. That's going to cut that base into 9 and 9. It's also going to cut this into a 30, 60, 90 triangle where I know the shorter leg. So yes, that 30, 60, 90 stuff is not going away. It's here, and it will be in Algebra 2 as well. So the more we can solidify that in our heads, the better off we'll be. So looking at this, my height is now the longer leg of that 30, 60, 90. So applying my longer leg rule, the longer is supposed to be the shorter times the square root of 3. So 9 square roots of 3 is my height. Now here, we are going to try to leave our answer in simplest radical form if we can. So basically, I'm going to multiply all of these numbers that are the coefficients in front of that square root of 3, and I'm going to end up with 81 square roots of 3 inches squared. So my final step, I found this entire sector. Then I found just the triangle. So if I can take the area of the sector and subtract the triangle, I'll have my final answer. So step 3, you may want to add to your notes, is going to be to subtract. So with that, I'm going to say 54 pi minus 81 square roots of 3. Now technically, we do need to include our units here, but we have left this in simplest radical form as much as we can. So if they do not say that we can round, this would be our final answer. But they do say up here we're going to round to the nearest tenth. So now I'm going to type in my calculator 54 pi minus 81 square roots of 3. And I'm going to end up with approximately 29.3 square inches. So again, if they don't specify, either of those are okay. Since they said the nearest tenth, the last option there would be better. The next one here, find the area of the segment again. So step 1, like we said, is to find the area of the sector. So take your measure out of 360 times pi r squared. So we've got 90 out of 360 times 4 squared. That's 4 pi square meters. Step 2 is to find the area of the triangle. So we do that by 1/2 base times height. And what's really nice about this particular question, if I turn this just a little bit here, that 4 is the radius of this circle, right? It goes from the center to the edge. So with that, that means this radius here is also 4. So I've got 4 and 4 as my base and height. So 1/2 of 4 times 4. So that's going to give me 8 square meters. Step 3 is to subtract. So my final answer is 4 pi minus 8 square meters. Or if we're told to round to the nearest tenth, 4 pi minus 8 is approximately 4.6 square meters. Guys, there will not be a ton of these on your test, but there will be one of these coming your way. So please make sure that you understand this process here of what we're doing. So again, our first step is to find the area of this entire shaded region. Then find the area of this triangle here so that we can subtract. And what we're left with is that segment of the circle. At this point, you may proceed to the practice. If you have any questions, please let me know.